12.6 planes. We'll have just a simple introduction to planes for this video. This is included in part of problem set number 3, and then problem set number 4, we will take lines and planes quite a bit further. But right now you're just getting used to basic equations. Here's the plane equation: a times x minus x0 plus b times y minus y0 plus c times z minus z0 equals 0. ABC in this case is a normal vector. It's perpendicular to the surface x0, y0, z0, some point on the plane, some fixed point. Where this comes from, I can give you a very simple demonstration. You can pick some point x, y, z in the plane, and then it turns out this vector, which is going to be, let's just call this vector v. That's x minus x0, y minus y0, z minus z0. It turns out these two vectors are perpendicular. And the other name for this is orthogonal. Two orthogonal vectors have a dot product of 0. So guess what? If you dot that on that, you have this, and we can set it equal to 0. It's as simple as that. If the plane's up here, it won't have a dot product of 0. If the plane's below the plane, it will not have a dot product of 0. The dot product equaling 0 precisely expresses all vectors, all points for which this vector will be perpendicular to this vector. So one minor difference with a line way of parallel vectors with a plane way of perpendicular vectors. That may cause a little bit of confusion. Here's a very simple problem. Find the equation of the plane including the point 257 and perpendicular to this 1, 2, 3. 1, 2, 3 is the ABC vector, and 257, it turns out, is the fixed point x0, y0, z0. So, okay, let's state the plane equation. Good idea to write it down. And of course you can identify the variables here. And then equals 257. And of course we're going to substitute 1 times x minus 2 plus 2 times y minus 5 plus 3 times z minus 7 equals 0. Of course, you can do some algebra. You can write this as x plus 2y plus 3z equals negative 2, negative 10 is negative 12, negative 21 is, and we get 33. And that is the plane equation. So, okay, here's another question. Question number 2. Find the plane including 158, but perpendicular to xyz equals 101 plus t times 0 to 5. Now keep in mind this is a line. You can draw a little picture here, helps you to sort things out geometrically. There's our line, there's our plane. Line's perpendicular to the plane. One thing we can extract from the line equation is a parallel vector, 0, 2, 5. That's parallel to the line, so you can draw that that is 0, 2, 5. Now, since it's parallel to the line, it must be perpendicular to the plane, so that is the desired vector that we need. We have a times x minus x0 plus b times y minus y0 and so we really need to identify a, b, c, the vector, and x0, y0, z0. You call it x naught if you want. N-A-U-G-H-T, naught or 0, doesn't matter. Now it's more letters, less syllables. Take your pick. ABC is a vector that comes out of this line equation. 0, 2, 5. Oops, that's the starting line. X0, Y0, Z0, that's given right here in the problem, 158. Now we simply substitute 0, 2, 5, 0, 2, 5 goes right here. The other 158 goes right here. And so we have 0, x minus 1, plus 2, times y minus 5, plus 5, equals 0. This whole term drops out, and so you can simplify this to 2y plus 5z equals negative 10 and negative 40 is 50 on the other side. And there is our plane equation. So, okay, straightforward problems, but you need to solidify these basic concepts so that in problem set 4, we solve some more sophisticated problems. So that's a good way to proceed. Get the basics down first, and then move on to the more difficult problems. That's why we separated this into 2 problem sets. So that's all for this video.